that variable. Is that okay? Yep. So it's a reasoning that is more important. The syntax and the derivation is kind of more mechanical than anything else, but the rationale behind it is more important. Do we have any questions about this? So we have just spent half an hour and accomplished the two objectives that I mentioned at the beginning of the class. Okay, one, to illustrate how to handle conditional statements, and two, why it is important. Because in this case, we have just proved that the algorithm is correct, and without having to throw any test cases at it either. It has to be right. Okay. Any questions about this? No questions? Okay, if there are no questions about this, instead of going into loops right away, we'll take a look at some interesting multi-branch conditional statements. Because if we can do a regular if-then, else, can we do a if-then, else-if, else-if, else? Okay, that's what we're looking at. So we'll do something that's a little bit not so smart. Okay, we'll do something that's not really so smart. I'll say, if x equals to 0, then we go to line 2. We'll just pick something to do here. Okay, that is not important. Else, if x is different from 0, then we go to line 4. We say z equals 2. Z gets 2, I should say. And then we go to line 5. We say else. And then we say go to line 6. And we say z gets 3. And line 7. And if. Most of you probably already see that this algorithm has quote-unquote a problem, right? The problem is line 6 is a dead branch. We should never be able to get there, because when we evaluate a multi-branch conditional statement like this, we always have to evaluate from line 1 to line 2, top down. Whenever the first condition is true, we execute that particular branch, and then we get out of the conditional statement. So that means line 6 is not really reachable, because the condition of line 1 and the condition of line 3 should cover all possible cases. X is either 0 or not 0, cannot be anything else. Okay. But it does serve an important purpose, because we want to look at the precondition of line 6. Does it have a precondition? And if it does, what is it? That's what we're going to do here. All right, so we'll go ahead and do the same thing here. I'll just say the precondition of line 1 is true, which means I know nothing about z or x before this algorithm. And then we'll try to find out, okay, at the end of the entire algorithm, what do we know at that point? Okay, so this is pre-1. We can say what is pre-2. Okay, pre-2 is easy to deal with. Pre-2 is pre-1, because whatever is in pre-1 still has to be true before line 2 executes. So it is important to refer to it as pre-1. And by the way, pre-1 is not necessarily true. It's just that in this case, I want to make it true. So it's pre-1 and whatever the condition is on line 1, which is x equals to 0. So just put it here. And then we do the same thing here. Pre-1 is true, true, and whatever is whatever. Go? Yep.
For pre-1 to be true, does that assume that x is a positive integer?
No. By saying that, by saying the precondition of line 1 is true, simply means we know nothing.
I asked that because I think a line 6 could be a negative integer.
When we get there, we'll see. So pre-2 is this, and then what is post-2? Post-2, okay. It's the same thing, but I'm gonna just be redundant here. The right-hand side of line 2 does not refer to the left-hand side. Use forget rule. Okay, so when we use the forget rule, it looks like this. It's the pre-2, we forget something in it. Anything that we state about z, we have to forget. And then after that, we know z equals 1. Let's see, pre-2 is x equals 0. Which doesn't mention anything about z. So that's why the effect of the forgetting is there's nothing to do. That's the conclusion of post-2. Any questions about this?
Isn't putting forget for pre-redundant?
Sorry?
Isn't putting forget for pre-1 redundant, pre-2 redundant?
It is redundant, but mechanically this is what we do. So that we apply the same technique regardless of the actual situation. So in this case, yes, there's nothing to forget. So I could have just jumped all the way to the third line, but mechanically, because I don't know whether pre2 actually has anything to say about z, we still want to do it this way, so that this particular way of doing things is universal. It doesn't matter, what it really is. We just apply the same technique. Yep.
So in our homework, you want to see it done this way?
Exactly. Yep. I want your homework to use the same template. So you tell me why you choose a particular rule, and when you apply the rule, you apply the template first. I consider this part as a template, and then you expand the precondition to whatever it is, and then you apply the actual operation with the result.
Okay, maybe I'm so confused though, because what do you mean by like the right hand side is referred to the left hand side? Oh, that's a stupid question.
In an assignment statement, this is the right hand side, and this is the left hand side.
Okay, that's exactly what I thought it was.
Yeah, it's referring to the right hand side and the left hand side of the assignment symbol itself, which is the left arrow.
All right, thanks.
Yeah, no, that's good. It's good to clarify. All right, so post 2 is done. Let's see if we know anything about pre-4. Okay, now pre-4 is a little bit more difficult. Okay, how do we get to line 4? Okay, this is basically saying what do we know right before we execute line 4. Now, right before we execute line 4, can we still say whatever is that pre1 specifies still has to be true? Yes, because we haven't had a chance to change anything yet at this point. So pre1 still has to be true. What about pre2? Can we say whatever is in pre2 has to be true too? Sorry. Whatever in condition 1, can we say this? It's quite the opposite, right? Because if x equals to 0, we would have executed line 2. To get here means x equals to 0 has to be false. Okay? So that means I put a negation here. And there's one more thing. In order to get here on line 4, the condition specified on line 3 has to be true. Right? If you just look at this as a general multi-branch conditional statement, whatever is specified on line 3, whatever condition is specified on line 3 has to be true for us to end up on line 4. So in this case, that is x is different from 0. Now I know it looks redundant because it is supposed to be like that in this particular case. So next we just expand all the terms. Okay, pre1 is true. It is not the case that x equals to 0 is the same as x is different from 0. And then we have x is different from 0. Okay, the true is easy to get rid of because we know true and whatever is whatever. So now we end up with x is different from 0 and x is different from 0. Is there a way to simplify this?
Yeah.
Yep. You just have to mention it once. Mentioning it twice doesn't change the meaning. Okay, so pre-4 is just that x is different from 0. Okay, so we go through almost the same reasoning.
Professor?
Yep.
So can't we just mention it once after the true? After we mention that it's true and then we mention it's not, and then we mention that x is different than 0. Can't we just mention it only once after that line? We have to expand it all the time.
Okay, let me see if I understand your question. So you're mentioning, are you mentioning from here to here?
Yes.
I just do it step by step, line by line. So this way, I'm not combining different steps into one single step. As far as your homework assignment is concerned, this line is mandatory. You have to expand it out to say, okay, this is the original form. And then you have to get to this line here, which is the conclusion. But in between these two steps, I like to perform that in the class because I want to show everyone as clearly as I can how do we go from one step to the next. Okay. So if you're familiar with this stuff already, yes, you can probably skip a few steps to just get to the conclusion. All right. So now we're on to line 4. Copy and paste. Just change line 2 to line 4. And Z gets 2. 2. Okay, now this part is a little bit different because what is the precondition of line 4? Well, it's x is different from 0. Okay, so x is different from 0. This goes here. This is 2. This is different from. And we are done with post 4. Are we still doing okay with this program? Okay. What about line 6? Okay, how can we get to line 6? Or what is the precondition of line 6? So let's try to figure that one out. The precondition of line 6 is 3(1) still has to be true. Because if I get to line 6, it means I have not executed any branches in the entire multi-branch conditional statements yet, which means I haven't got a chance to change anything yet. Whatever is in pre-1 still has to be true at this point. But in order for me not to execute line 2, it means the condition of the first branch on line 1 has to be false. So x equals to 0 cannot be true. In order for me to get here, it also means that line 4 cannot execute because I would have executed line 2, line 4, and then I'll be done. So to get to line 6, it means the condition of line 3 also has to be false. So not x is different from 0. Yep.
Are you saying line 3 has to be false or line 4 has to be false? Because if you went from line 2 is false, then you're going to execute line 3, right?
Correct. So pre-1 has to be true because we haven't had the chance to change anything. The condition of line 1 has to be false because otherwise I would have executed line 2. The condition of line 3 has to be false because otherwise I would have executed line 4. So that's why we have this one here. It is the negation of the condition of line 1 and the negation of the condition of line 3. Is that okay? All right. So now we take this and say, well, what does that really mean? Okay, pre-1 is true, we know that. X is equal to 0 is, x is different from 0. And not x is different from 0 is, well, we'll keep it here. Not x is different from 0. Okay, I intentionally did not simplify this one so that we can do something to get to the answer. Okay, so we have something that looks like this. We have basically, some value, x and not x. Okay, what do you think is x and not x?
An error?
No, it's not an error. Well, let's work this out. Okay, let's work this out. In the truth table. Okay, so we'll work with the truth table here. We have x and not x, and then we have x and not x. Okay. So let me put parentheses around not x so that we are clear which column is which column. Okay. So in this case, we have one single variable because not x is not a variable. It is an expression based on the only variable that we have. X is Boolean. So what can it possibly be? True or false? 0 or 1. Okay. So in this class, we say it's true. It can be false. If x is true, what is not x? False. And if x is false, what is not x? True. Okay. What is true and false? False. What is false and true? False. Wow. So that means I don't even have to know what x is. I already know what is x and not x. It has to be false. Is that okay? Now this is important because what this is saying is I don't care what x is.